reaction types illustrate the types of decomposition that you may see on this assignment that I gave you, and I'll take a look at the assignment in just a second and show you what I'm talking about in the context of the assignment. So this is an acid. Now, I haven't really talked to you very much about acids. Acids always have an H in front. So that's an H in front right there. So we know that acids will make a non-metal oxide and water. All right, so metallic carbonates make a metallic oxide and carbon dioxide. And we know it's a metallic carbonate because it has a carbonate in it. A metallic hydroxide makes a metallic oxide and water, and we know it's a metallic hydroxide because it has a hydroxide ion in it. Acids make a non-metal oxide and water. We know it's an acid because it has an H in front. And metallic chlorates make a metallic chloride plus oxygen. So we know that it's a metallic chlorate because it has a chlorate ion in it. That's ClO3 down at the bottom. All right, now let's take a look at the actual assignment that I'm talking about. So this was in Google Classroom, and about 10 of you have already turned it in. And for those, and if you turned it in, you probably took time to do a lot of looking up stuff to see how to figure it out. In other words, or else you just took it a bunch of times until you remembered what was right. So here we go. And this was the predicting products assignment. 8 of you have turned it in. Okay, so this is what it looks like. So see, this is a metallic carbonate. So based on what we just said, the metallic carbonate makes a metallic oxide and carbon dioxide. So your answer has to be the one that's a metallic oxide. The next one, that one doesn't, not, this is one of them, or 5 of them like this in this assignment that have this. You recognize it's a decomposition because there's only one thing over here on the left side of the arrows. So that decomposition is going to turn into a metal oxide plus water. So that would be this one, a metal oxide plus water. This one is a straight up decomposition, so it's going to make silver and oxygen. Remember that the oxide is called IDE. It ends in IDE when it's in a compound, but when it's by itself, it's just a plain element. You call it oxygen. Here's another one of those decomposition ones. So this is an acid, just one thing. And acids, we said, make a non-metal oxide plus water. So that would have to be this one. There's the non-metal oxide plus water. There's a metallic hydroxide. And that's one of those 4 we talked about. So the metallic hydroxide makes a metal oxide plus water. All right, and then this one's not one of them. That one's a metallic chlorate. So it makes a metallic chloride plus oxygen, is what the rule said. So now go back to the window, and if you pin the window, you might want to take a picture of this piece of paper. Let me write down what this is. This time I wrote the symbols because in my mind they run together. All right, that's what those 2 things are. All right, going to take a picture of that. That way you'll have it in your phone. You can easily do that assignment then if you don't have it done yet. All right, any questions about understanding what I mean by these decompositions? So I'll wait for a minute. If you want to ask something, you can throw it in the chat or you can talk out loud.
I just got here.
Okay. So
can you make a picture bigger somehow?
Do what?
Can you make the your screen bigger somehow so I can take a picture?
What you can do is, if you click on the picture of this piece of paper, you should be able to pin that window. Did you try that? Try that and see if it works. Does that do what you needed it to do?
Yeah.
There you go. So as I'm writing, today I'm going to write on a piece of paper a little bit, and as I'm doing that, you want to pin, probably. All right, everybody got it? Okay, so now I want to go back to the predicting products, and I want to make sure that you understand how to predict, not to predict the products, how to recognize the reaction type. So I'm going to review just a little bit more. And Jakaya, this is one of the assignments that you're missing. So, but it's related to the cut and paste activity we did last week. So it's one of the things we did last class. So if you look at this, actually let's just use the same one we were just on. All right, so this time I don't want you to actually tell me what is produced. I just want you to tell me what kind of reaction it is. So can we just do some shout outs here? You guys just say what you think it is. So this is sodium chlorate. It's got an arrow. Is it synthesis, decomposition, double replacement, single replacement, or combustion? Those are the 5 types that we categorized last week. So which kind of reaction is that?
Decomposition?
Yes, because there's one thing making 2. What about this one? So in a minute I'm going to give you a little quiz on this with about 15 questions on it, where I give you the reactants and you tell me what the products are. So you don't tell me what the products are, you tell me what kind of reaction it is. So what kind of reaction is this? Be sure you got it, and we'll run through 20 of them right now for practice. Shout out.
People in the chat too.
Oh, okay. Let me see. I haven't got the chat up here. Hang on. Let me see if I can get it out. Okay, so I see this one, the first one was decomposition. You can write them in the chat now. I've got it up where I can see it. This one is not a synthesis because this is a hydrocarbon. See, that's got a hydrogen and carbon in it. So hydrocarbons plus oxygen are always called combustion, and they're going to make carbon dioxide and water. They always do the same thing. All right, so that one's combustion. You can recognize combustion because it's going to have oxygen by itself and it'll have a hydrocarbon here. This, by the way, is a reaction that's in a cigarette lighter, or one of those lighters that the long stick lighters you can light a fire with. That's what this is. All right, calcium acetate, sodium carbonate. What kind of reaction does that look like? Either chat or say it out loud. Double replacement I see is in the chat, and that's right. And we know it's double replacement because it has a metal and a polyatomic ion, or metal and a nonmetal, metal and nonmetal. And what happens here is the sodium goes where the calcium was, and the calcium goes where the sodium was. That's why it's called double replacement. How about this one? Combustion's right, you guys. That's good. Combustion, because you're combining with oxygen and it is a hydrocarbon. No big deal if you spell it wrong. All right, how about this one?
Double replacement?
Yep, that's a double, because you got the same situation we had a minute ago. Yeah. How about this one?
Synthesis?
If it was synthesis, there would be a plus sign over here. So since you don't see a plus sign, how many things do you actually see right there? And it's just one thing. So that's going to have to be one thing turning into something else. So it's going to be a decomp. That's a decomposition. And that's the one that we talked about a minute ago. It's an acid, and it's going to make a nonmetal oxide and water. So the nonmetal oxide, well, you know that it has to be either A or B for the answer, but sulfur is not an oxide because it doesn't have oxygen in it. So the answer would have to be B, sulfur trioxide and water. Okay, how about this one? I see Maggie knows what she's doing here. That's synthesis. That's right. Do you all agree with that? Is everybody with me? Hi, Trinity. I didn't see you come in. Good morning. All right. Next one. Now, here's one that's different. We haven't run into this yet, but this is a compound here plus an element. So what kind of reaction is this? This is a compound. This is an element. Yeah, that one is single replacement. So what happens is the bromine goes where the iodine was. We actually have done this reaction in the lab. This is back in the fall. We did a lab on halogen identification or halogen activities, and we had this would have turned the layer at the top of the test tube purple. You guys may remember that lab. So the bromine pushes out the iodine, so you end up with sodium bromide plus iodine, and then the iodine shows up as a purple layer in that test tube. And that was, you may remember that from October-ish or November. All right, moving on. What's this one? Combustion's right. This one? Synthesis is right. Now I'm going to confirm answers quickly as I see them. I need you to tell me if you are confused by it. But don't wait till the end and say I didn't understand anything. Tell me as we go. What about that one? I agree with synthesis. Everybody else okay? Good. This one? Okay, this one is not, what's missing right there? There's no plus sign, is there? So since there's no plus sign, it's a decomposition. And that's one of the ones that we talked about at the beginning of class with the metallic carbonate. Decomposes to make a metallic oxide and carbon dioxide. So the answer would be C on that one, if you're actually completing it. All right. How about this one? 2 elements. Synthesis is correct. How many identities on the left side? Is that one thing or 2 things right there? It's just one thing, so what kind of reaction is it? It's a decomposition. 2 elements again. Synthesis is right. Good. An element and a compound. Element and a compound. Single is going to be right. Because what happens is the magnesium replaces the hydrogen, and so you get magnesium nitrate, and then hydrogen is by itself. How many identities on the left side of the arrow? Is there one thing or 2 things over there? Just one thing. So that's a decomposition, because metallic hydroxides are going to make metallic oxides and water. How about this one? That one's a double, because you've got a metal and a nonmetal, and then the acid has the hydrogen is not really a metal, but phosphate acts like a nonmetal. Hydrogen has a positive charge, and in that regard, it acts like a metal. All right, so that's a double replacement. When you see 2 compounds, they're always going to be double replacement in this activity. All right, how many identities on the left side? So 1 identity, which means that's going to have to be a what kind of reaction? It's a decomp. And if you look back at your picture, you'll see which one of these is the correct answer, because metallic hydroxides make metallic oxides plus water. So the answer has to be C. All right, and then this one, you got, this one's a little weird. Is this an element or a compound? So that's a compound. So you've got a single element plus a compound, which means it is going to be a single replacement. All right, now let's try this real quick. All right, quick, what kind? Decomposition. What kind? Combustion. What kind? Double. What kind? Combustion. Double. Decomp. synthesis. Element, compound, so single replacement. Combustion, because of the hydrocarbon. Synthesis, two elements coming together. Synthesis, two elements coming together. Decomposition, there's only one identity over here. Synthesis, two elements coming together. Only one identity, decomposition. Two individual elements, synthesis. Single replacement, because it's an element plus a compound. Decomposition, there's only one identity. Double replacement. Iron 2 hydroxide is going to make a iron oxide in water, so that is a decomposition. And the last one is a single replacement. All right, are there questions? Okay, so now we're going to take time to do a little Google form quiz. It's going to be, I'm going to give you about 15 minutes to do it. So we'll take a 15-minute stop of what we're doing here, and I'll show you what it looks like first, and we'll start. All right, so, and the quiz is going to, I'll show you what it looks like, and we'll talk about it first. So I'm going to pull back up my screen share again, sorry about that. So here we go, and we go classwork. It's a quiz, reaction types and prediction. Edit it, and assign it. All right, so it's going to pop up in your Google Classroom. It's going to look like this. So the way this quiz works, you're going to look here and identify which it is. There's one of each on this list. Good. Okay, so there's one of each. So you'll only, like if you use single replacement for this one, then it won't show up. You won't be able to use it again. So you understand what I mean? So there's five reactions, there's 5 types, there's one of each. All right. So now we're going to take 15 minutes and come back at 9:20.